Assalamu alaikum everybody. Today I'm going to tell you about support vector machines and the SVM model, and we'll just discuss the basic theory, how it is implemented, and then we'll look at the practical aspect by using Python, and I'll show you some results. So let's start. A support vector machine is a supervised machine learning model that uses classification algorithm for two-group classification problems. After giving an SVM model a set of labeled training data for each category, the SVM are able to categorize new data. How it works? The basic support vector machine and how it works are best understood with a simple example. Let's imagine we have two tags, red and blue, and our data has two features, x and y. We want a classifier that, given a pair of xy coordinates, output if it is a red or a blue. So we are going to plot this training data and see how it look like. Okay, you can see that on the left side there are circle blue dots, and on the right side we have some red triangles. This is our label data, and if you can see, there is a margin here. This is a simple data, and if you want to classify, if you want to put a classification boundary, you can put it here. A support vector machine takes these data points and outputs the hyperplane, which in the two dimension is simply a line, as I have shown earlier, that separates the tags. This line is the decision boundary. Anything that falls to one side of it will classify as blue, and anything that falls on the other side will be classified as red. As you can see, on a two-dimensional hyperplane there is a simple line. This is the best hyperplane that is possible with these training data, and if a new data point falls in this area, it will be classified as red, and if it falls here, then it will be classified as blue. For SVM, the best hyperplane or the decision boundary is the one that maximizes the margin from both tags. In other words, the hyperplane whose distance to the nearest element of the tag is largest. As you can see, it is going to find the largest distance from both tags, and then it's going to draw a line. You can see an example here of different hyperplanes, and the best one is shown with the black line, and the gray one is also a hyperplane, but it's not that good. So this is the basic principle of SVM, and this was a simple thing. But what happens when there is a non-linear data? Since the data in the previous example was linearly separable, we could draw a straight line to separate red and blue. But the things are not that simple in real life. Let's look at this data. It has again the red and blue tags, but the problem is that you cannot draw any line anywhere which can separate these two classes. So in this case, we have a method which we are going to see. So to get this problem solved, what SVM does is it adds a third dimension. Before we were having only two dimensions, x and y. Now we are going to create a third dimension, the z dimension, and the rule that it can be calculated a certain way that is convenient for us, that is z is equals to x square plus y square, and you know that is the equation of circles. So we are going to use that to create the third dimension space, and then taking a slice of that space, it is going to look like this. So if you now see these two, if you want to separate them, you can draw a line here somewhere that is going to separate these two classes. and the view you are seeing right now is the third dimension, and this could be the best hyperplane considering the data available. Now if you go back to your original view, then you can see that hyperplane is coming out to be like a circle here, so it is basically classifying the two. If something is falling in this area, it will be classified as blue, and falling in this area will be classified as red. Okay, let's look at the example implementation of SVM using Python, and the library I'm going to use is Matplotlib, which is going to show a very realistic type of view, and which is going to be interesting and very easy to understand the concept. And for that I'm going to create a data which is going to be in circles. These are some codes. I'm not going to explain these codes. I'm just going to show you the results. Once I run this, and the first thing I get is the data, and you can see the data are in circles, and the circles, one is showing, the outer circle is in something like dark blue, and the inner circle is yellow. But the view you are seeing right now is in 2 dimension, but because, as we have discussed earlier, it cannot be separated in the second dimension, 2 dimensions, so we are going to create a third dimension for this. And once you want to see it, this is the data, the one which I showed you previously. Now we are going to see how it can be projected to this third dimension, and you can see here that the data is now can be linearly separable from this point. And when you run the SVM algorithm, you will see again the data, and it's going to show this line here, this separation boundary. And if you want to see it like this, you can see that the line is present in the third dimension, and it is easily separating the two classes. So this was the practical implementation. I hope you understand this concept and the working of the algorithm, and you can try it on Python, and you can produce different result with different data. Okay then, thank you very much.